This meeting is being recorded.
Dime quem eu dou. A very warm good evening to one and all. Welcome to day 3 of our FTP. We have an exciting lineup of sessions today, starting with our first session on quantum algorithms for machine learning. It is my privilege to introduce today's distinguished resource person, a well-recognized expert in his field. His remarkable achievements and contributions make his introduction a task in itself. It's no exaggerations to say he's an accomplished and inspiring personality. The honor goes to none other than Dr. Anand Nayyar. Dr. Anand Nayyar is a distinguished academician, researcher, and technologist in the field of computer science. Currently, is serving as a professor, scientist, vice chairman of the research department, and director of the IoT and Intelligent Systems Lab at the School of Computer Science, Newton University, Vietnam. He completed his PhD in 2017 from Desh Bhagat University, specialization on wireless sensor networks. Dr. Nayyar sir is a certified expert with 125 plus professional certifications from renowned organizations such as Cisco, Microsoft, Amazon, Oracle, and Google. His scholarly contributions include over 200 research papers published in prestigious journals and conferences, 60 plus book chapters in reputed publications like Springer, Whaley, elsewhere, and authorship or editorial contributions to 60 plus books. His research has garnered the 16,000 plus citations in Google Scholar with an H index of 67 and I index of 258, establishing him as a global leader in academic research. Dr. Nayyar holds 90 plus patents in AI, cloud computing, IoT, robotics, and healthcare domains across multiple countries. He has received 50 plus prestigious awards, including the Obada Prize 2023, Lifetime Achievement Award 2023, and Distinguished Scientist Award by the National University of Singapore. And notably, he has been listed as among the top 2% of scientists worldwide by Stanford University. Now, Dr. Nayyar sir is a senior or life member of 60 plus professional organizations, including IEEE and ACM. He serves as an editor for high impact journals like IEEE Transactions on AI and has reviewed over 5,100 articles for top tier journals. We are very honored and we are very fortunate to have you here today, sir. Uh, his sir research mainly focuses on AI, IoT, cloud computing, blockchain, cybersecurity, SWAM intelligence, healthcare informatics, big data, and wireless communication. His work reflects a strong commitment to advancing a global technological and innovation and knowledge. Thank you, sir, for accepting our invitation and being here today. We are very grateful to have you here today.
Evening, ma'am. Thank you so much for such an elaborative introduction. In fact, it's indeed my honor that I'm part of this quantum computing FTP. In fact, if you talk of quantum computing even today, it's like a myth for even for me that will we see the future and when we will handle or when the common man will be able to see quantum computer in his or her own labs. So still we can say, but still we can say that just yesterday Google made a big remark in quantum computing based chip, which I will be discussing today. And we have lots of things to be discussed one by one in this lecture. So let me first of all present the screen.
Yes, sir.
Can you see my screen, madam?
Yes, sir.
Okay, perfect. Okay. So, good evening, ladies and gentlemen. I'm Dr. Anand Nayyar, and I'm working as professor, scientist, vice chairman research, and director of IoT and Intelligent Systems Lab. First of all, it's a real honor for me to be the part of this FDP program from Atal, which is on quantum computing. In fact, when Madam Shilpa Reddy has given me the invitation for quantum computing, in fact, I was a little bit shocked that quantum computing is still like on the pre-starter phases and only like Google, Microsoft, and a handful of companies are only contributing, and few open source developers are there that are actually producing some open source simulators. But still, it is a myth that you can say that what is the future? Still, we don't know. But still, it's a really, you can say, a bold step from Madam Shilpa Reddy that she is organizing this type of FTP on the futuristic computing, which we know as the quantum computing. Mr. Dayanand, is the full screen not visible? Hello?
It is
Madam,
visible.
screen is not visible?
It is visible, sir.
Okay, but one person has told that it is not visible. Maybe he has to set the network connection. Okay, perfect.
Yes, sir.
So before, ladies and gentlemen, I would like to give you a brief introduction about me, about my lab, as already Madam Shilpa has given some introduction, but I will not give you a detail about my profile, but I would like to tell you briefly about my lab, what exactly we are doing. And of course, then I will be starting with the agenda. I'm having 3 presentations in front of you. And after that, if the time allows, I will be going to some online websites, showing you some quantum computing websites, some simulation website. And of course, I will be giving you little bit of hidden resources that are associated with that. But trust me, everybody, before I start this FDP program, I will be very honest with you. Quantum computing is not my area. Quantum computing is absolutely not the area that I'm working. In fact, none of the person in Vietnam is working. I'm having some connections in China and of course in US. They are a little bit working, but still they say that publishing the paper and of course right now leading to some conclusion orientation towards novelty, it's still a big challenge. Okay. And in fact, if you search quantum computing journals, you will find that there is only 3 journals which I will be telling you. In fact, none of them are even right now Scopus indexed. So which means that still this field is corely new, but we have to wait for like couple of years. In fact, we have to wait for 2 or 4 years more when we can have the first journal of quantum computing, which will be Scopus indexed. But that again depends on Scopus. Okay. So everybody, let's not waste the time and let me start with some introduction and agenda. So here you can see my photographs. On the left hand side, you can see my photograph of Google I/O event. And last year, my lecture on Industrial Internet of Things has been got the best lecture award. And considering my teaching and research expertise, and of course my contributions towards country, so University of DTU, that and along with the Da Nang government, they have given me the best teacher award, best professor award. In fact, I'm getting the best researcher award from last 6 years. I'm the highly decorated foreigner in Vietnam. So here you can see my photograph of LoRaWAN communications. We have designed our own LoRaWAN communication. And this is right now being challenged is also with the industry because most of the industrial LoRaWAN communications start from $7,000 to $15,000. We designed our LoRaWAN solution in less than $2,000. And in fact, right now we have the US patent for this. That means that we are having the coverage of LoRaWAN sensor nodes of mine own design by more than 1,877 kilometers. So here is the robot that is already being designed and implemented at the Da Nang International Airport. And we have already integrated large language model just 10 days before. And now if you come to Da Nang city, you can even talk to this robot in more than like 37 languages. The robot will learn from you. It can even interact with you. In fact, it can guide you what exactly should be your plans. It is directly connected to ChatGPT. And you can even book your flights. You can even cancel your hotel tickets. You can even rebook hotel tickets. And in fact, it can give you the complete itinerary. And we are very proud that the results from the last 10 days is really, really amazing. And this is a smart owl. And if you have an Alexa today, that Alexa is actually giving you the current state. So if you can integrate this smart owl, you can even, in fact, get the predictions that what exactly should be the next actions for your host smart home. Like suppose moisture is increasing. So let the smart owl will give you the recommendation that, okay, AC should be on and this room is vacant over there. So let the smart owl gives the prediction about your smart home. And we are seeing lots of budding applications in real time, smart cities, and of course, industrial IoT. And this is the drone that is being invented by us. And right now we are working on autonomous drones, which I will be telling you in a couple of slides when we move ahead. So my introduction is already done. So right now I'm sitting on 17,000 citations with H-index of 68. I'm expecting to get by 70 by next 20 days. And of course, I'm having my H-index of 50. I'm one of the top decorated scientists in the whole world with 51 awards, 125 plus patents, 100 books, 10 inventions. And right now I'm acting as the top 700 scientists in the world. And in fact, on research.com, I'm among the top 5,000 scientists across the planet. And in computer science, I'm among the top 250 people in the whole planet. So this is my office and lab, and you can see that we have the top systems using Intel, NVIDIA, and AMD technology. And we are doing our crypto mining also. So we have many machines which are using Antminer S19. In fact, I was telling Madam before the start of this lecture that apart from being an academician in Dutan University, I'm also running my own company in Hong Kong, and we are having our own customized mining farm. So I cannot tell you more about my company. So It's like a mining farm, and we are having more than 50 machines, and 6-7 are even designed by me. And very soon we will be putting our first solar farm that will be integrated with that, so that we can reduce the electricity cost. And we are integrating very heavily with that is called your Ada Lovelace chips and RTX 4090 chips. And this is my robotics lab, and you can see that we have all kind of robots. And if anybody wants to visit my robotics lab, you are most welcome. And I'm going to tell you right now, it is going to blow your mind that one of the Chinese company has given us some parts, and we are getting regular parts from Taiwan, and some of the parts have come from Boston Dynamics. And this is the outcome, everybody, that this is the work in progress. And I hope you have seen this robot in lots of discovery channels and everything. And this, if you see over here, this is LIDAR. So right now we are working on LIDAR technology, and very soon I will be making this robot a complete autonomous robot for industrial IoT applications, and of course for military and battlefield applications. And this is my drones lab. We have the state-of-the-art drones. We are working on FPV drone. We are working on RC plane. We are also working on autonomous drones, especially for the night vision. And of course, we are working for smart farming, industrial IoT. And very soon we will be also working on drone racing, which I will be showing you right now. These are the FPV drones being designed by us. And these are some of the equipments that are readily available. So you can see with CX20, we have the FlySky and we have DX5E, the top controllers, and we are all using these Java-based controllers in order to customize our own FPV drones. And this is the first working prototype of our RV plane remote vehicle. That is the DTU RC1. And you can see my photograph here. So this conference I have organized as like a conference co-chair on July 26 and 28. And this was the first time we revealed this prototype. And you will be happy to know 7 to 8 prototypes we are already developing. And one day, by you can say not next year, by 2026, these all drones will become autonomous, and they will be having the complete smart swarm technology that will be flying in the air for complete monitoring of the remote stations. And in terms of IoT Intelligence Systems Lab, we are working a day and night in terms of robotic arms. And right now you can see the efficiency and accuracy. And this is working with NVIDIA Jetson Nano. And we have good collaboration with NVIDIA, AMD, and Intel. And of course, Samsung. We have lots of funding from Global 30 based project, and Siemens also. So we are working for doctors in hospitals. In fact, right now I'm not giving any IoT lectures, so I cannot show you my other projects also. But this is all about the projects that we are doing main. And right now, by next year, we are efficient that the accuracy will even touch 91%. And this is the autonomous vehicle. It is almost 99% ready. And my master student is going to deliver this autonomous vehicle to the police, that we can go for the remote monitoring of the regions. In fact, for the farmers, that farmers just have to launch this vehicle in the farms, and the farmers will be getting all types of feed remotely. And they can be even getting alerts if there is pest or any germs in the field. So this is the working prototype, and you can see our exhibition right now. And these are some of the robotic kits that we have in our lab with regard to PyRacer. Shilpa ma'am, please mute the participants. Thank you. If the participants are not muting, please remove them. Please remove them from the meeting. Thank you. Hello.
Yes, sir.
Hello.
Yes,
Madam,
sir.
please remove them from the meeting. If a person is talking, it means the person is not attended. Please remove him from the meeting.
Yes.
So this is our lab and robotic kits. You can see with the PyRacer and robotic arm that we are having. And we are having the state-of-the-art Rex Evolution Robotics, in which we are going for swarm-based robotics for civil and architecture-based projects. And this is the Luca robot that we have already designed, and we are working with some military-based project with this type of robot. So right now, everybody, we are working as in our research grant, we are working for AkaChain project, that is to implement the first blockchain-oriented e-commerce website. And we are working for healthcare implementation for blockchain for 2 hospitals in Vietnam and Thailand. And of course, we are working on LLM-based AI project for business application. That is my project of $1 million under Vietnam Korea project under Global 30. So these are my links. In fact, you can just search my name on Google. Anywhere you can send me the email. You can follow me on YouTube. You can follow me on LinkedIn. You can follow me on ResearchGate, Orsted ID. Everything is open for you. In fact, regularly I write my articles on open source for you. In fact, you can see some of my articles on quantum computing with open source for you. And very soon, by March 2025, me and by one of my partner from Wipro, we are working on some of the open source quantum simulators based pros and cons. That is going to be the biggest article ever written in the country, in India. So that is where we are working, and we are working day and night to publish that article very soon. So these are the three mottos. So remember everybody, quantum computing is not today's computing, it is the future. So it is very important for platforms like this that we have to update our knowledge. We have to go for the better word, because tomorrow's word is not going to be your digital computing with binary digits or zeros and ones. It will be 1, 0, and even there will be the third state. That is the foundation of quantum computing. So we have to improve the knowledge of a better word. And if you are stuck in some problem and no one is supporting, relax. God wants you to learn many things. And that's the reason I don't say anybody is my mentor. I'm the mentor for myself, and I keep on improving. I keep on learning. And of course, in terms of quantum computing or anywhere where you're working, and that's what when Shilpa madam called me for her PhD, I always told her this thing, that madam, there is always challenge, there is always hardship. But if you're not facing challenges and hardships, there is no wonderfulness in the PhD. So remember, PhD and all those things that you're doing right now, it's all full of challenges and hardships. Consider yourself that at one time when computers used to take 2 to 3 minutes to start, and we were having the old computers like Windows 98 and XP and old school technology and games without even a graphics card. But today, remember, the technology has led to artificial intelligence. Now consider everybody about I'm a professor of artificial intelligence from last like 12 to 14 years. And when I used to go in the class, I used to study only the theoretical test like Turing test or those things like theory only. But today we have the AI tools. In fact, when I'm teaching research methodology, we are dedicating our lectures towards how AI tools can be used for research in effective manner. So remember everybody, challenges and hardships are part and parcel of our life. And because the only thing is very important for computer science is the change. So change yourself, update yourself, and always keep on learning. That is the main advantage of being a student of mine. So the agenda of lecture will be like these 4 parts. So first of all, we will understand what exactly is a quantum computer. Now remember everybody, we all know what is quantum computing, but what exactly is a quantum computer? So today, if you talk of your laptop, it has your screen, it has a CPU, it has a GPU, it has a keyboard, it has some touchscreen panel and all those things like input output devices. But what exactly will be the quantum computer? This is very important part, because many people talk about quantum computing. We will study about the superimpositions or logic gates and all those things, but nobody discuss that what exactly the quantum computer looks like and how it is different from our traditional computers, modern computers, and even the forthcoming future computers, which will be based on artificial intelligence. Second, I will be discussing about quantum computing and quantum machine learning. And because I'm not a mathematician and I'm not working in quantum computing, so I will be discussing the algorithms in front of you. In fact, I will be giving you my presentation. After this lecture, I will be replying to Madam Shilpa. You can take all my 3 presentations which I've designed today. So you can use it, you can update yourself. And if there is any problem, let me know, because I'm not specialized of quantum computing. I'm here to just deliver the lecture and give you the best of the knowledge, but more and more exploration is required at your end, and more exploration are required at our mutual ends, and then we can publish something. In fact, till date, everybody, you can see my Google Scholar, my Scopus, till date, we have not published any of the paper in quantum computing, because the problem is, what is the shed problem is that even though we try to write a paper, or we have effort like 1 or 3 months in that paper, but the problem is that the paper will not even get a Scopus index. In fact, many journals will even submit, you get your paper submitted and they will say that quantum is not a part of our scope. So you can say that there is right now the challenging situation that whether we should invest our time and effort in writing a quantum computing paper, or still we have to wait for 1 or 2 years and update our knowledge and wait for some core tools and applications to come about, and then we are ready for this quantum computing. But still,
Sir,
everybody, I have lots of questions.
sir,
Hello.
one sec. Yes, sir. Sorry to interrupt you. There is some pop-up showing on your screen. Mine means this the WebEx window is showing there.
Okay.
So it is
Okay.
somewhat
Is it okay
different.
now? Is it okay?
Yeah. Can you pull that away from your screen?
Just wait a minute. Is it okay now?
Yes, but it is still showing that minimized window. Yeah, that one.
Is it okay?
Yeah,
Is
yeah,
it
no,
okay?
yeah, it's fine.
Okay.
Sorry.
So we will be discussing about all these websites and all those things with regard to quantum computing simulators and quantum machine learning algorithms. But I have already promised to Shilpa ma'am that after this lecture, before we wind up, I will be giving all these presentations to madam on her email. So you are most welcome to share the presentations. And Shilpa ma'am, please give them the presentations what I will share after this lecture. Okay.
Sure, sir.
So So it doesn't matter where you start. The only thing is we have to begin. So let's begin our journey. So I assume everybody that you are already attending some of the lectures for quantum computer or quantum computing. I don't know what is the level of those lectures. I don't want to know because I don't compare myself with any other professor. I only believe that when I start my lecture, I start it as a foundation that today you don't know anything. So remember everybody, the beginning of wisdom is that I don't know. So start the lecture that today is the first day of the FTP. And if there is any problem, I will try to solve that problem as soon as possible because still we are working. We have published a little bit of articles, but not research papers. So let the journey begin, everybody. So I hope, madam, you can see the presentation. Thank you.
Yes, sir. Yes, sir.
Thank you so much. Thank you. So everybody, the agenda for today will be the three presentations. Presentation number one will be introduction to quantum computer. Presentation number two will be your quantum computing and quantum machine learning, which means the concepts, applications, and major players, which is very, very important for you to know. But trust me, everybody, right now, only Google and Microsoft are the chief players. But what exactly is happening from the industry, what I've seen till now, that only Google is the thing that is actually, Google is the company that is actually making the quantum world possible with this processor. But still you say that quantum computing is not very new. It has been started like 7 to 10 years back. In fact, if you go to YouTube channels like MKBHD, he is the most popular tech YouTuber. You can even search MKBHD with quantum computing and you can see they have even went to the Google quantum labs. But rest other companies, they are investing there at the back end. But right now Google is the forefront company running into quantum machine learning and quantum computer for the mankind. So the third part, that is the main part for the lecture today, will be the quantum machine learning algorithms. And again, everybody, I'm not a mathematician. I'm a math-based security cryptographer. Okay, but I will be producing some mathematics. You can see that I will be sharing this presentation and I will be opening up the algorithms till the best of my knowledge. Okay, but I'm not working in this area. So everybody, let us understand what is the introduction to quantum computer. Now, remember everybody, I'm not going to discuss about quantum computing. I first of all start with what is a quantum computer, what exactly it looks like, what are the components, and we can imagine what will be the technical concepts related to that quantum computer. So the outline for this presentation will be qubits versus bits. So remember everybody, today if you talk of your computers, it is working on bit, that either it is 1 or 0, either it is on and off. And that's how we have our gates. That is the AND gate, NOT gate, NOR gate, or any other gates. But in the future, we will not have only 1 and 0, we will have the third state also. After that, I will be telling you some brief history about quantum computer. Then we can discuss about the trends. But right now, the biggest news that is coming, you can just see on first post and even from Palki Chopra from that is your Beyond News, that Google has launched their first quantum computing processor. But still, you have to learn lots about the background before you can see that news and you can understand what exactly it is all about. So I will be telling you what's happening now. But remember, the future of quantum computing is not today. It will be started when we can have some real-time applications, when we can say that not only NVIDIA, but quantum computer and AI chips like from NVIDIA, they are combined together and they are powering some AI-based high-end applications. Like today, if we talk of 2 days before, now ChatGPT has launched Sora. So which means we require lots of training of the machines and we require many people to be coming and they will generate the videos. So remember this type of complexity of computing, or you can say in the future when we talk of the Ethereum based mining, which will be more. And of course, we have the Dogecoin mining and all those things will be coming. So NVIDIA and today's the central processing unit computers or APUs will not be enough. So for that, we need to have the quantum computer. But the first application which I would like to assure you today, because till date, if you talk of the most demanding resource requirement for artificial intelligence is not your text generation or natural language processing. It is not about your image generation. It is all about your video generation. So still, if you talk of websites like Kling, they are not very much efficient, but we can expect that when we go for the quantum computer, then we... Madam, can you do something about this, please?
Yes, sir.
Hello? Madam,
Yes,
can
sir.
you do something about this? I'm getting disturbed.
Yes, sir. I have muted all the participants.
And also చేసుకోవడానికి.
So the future of artificial intelligence will be the... Madam, if now that there is a disturbance, I would like to close the lecture. So the future of artificial intelligence is all about video generation and more types of complex code generation. So you can see that if today, if I want to make a complete blockchain based application with regard to mining or suppose like video generation, then I can say that this could be the realistic application where quantum computing can play the role. But still we need NVIDIA technology and other Intel based technologies to combine together as a cluster and as a one hand, and then we can perform something outcome. So everybody does first of all understand what is qubit versus bit. So I hope everybody knows about today's computer, digital computers. They are just having two states, either on or either off, 1 or 0. That's why we have the truth tables. But you can say if you talk of qubit, it's called the quantum bit. It means we will not have two states. We can have many possible states at the same time. And that's the reason you can see that quantum bit has infinite amount of information, and this information can be extracted using the measurement. And that's the reason everybody, when measured, quantum bit collapses, resulting in less than 0 or more than 1, with the probability that alpha and beta associated with the quantum latitude. So I'm not talking of 1 and 0 at the same time. I'm talking about many possible combinations that can occur at the same time. So remember, so today if your computer is either on or off, but today at one time with quantum bit, it can perform lots of different states at the same possible time. That's the reason you can see this formula in front of you. So we have the two states, you can say, which is equal to parallel computing, superposition and entanglement. So these are the two important terminologies that you need to understand as chapter number 1. So you can say, what is superposition? So superposition in very easy terms means that quantum bit can be in more than one state at the same time. Now remember, if you start a fan, either it is on or either it is off. It is in the one state. It is off, yes, it is one state. It is on, yes, it is in one state. But remember, in superposition, there is more than one state at the same point of time. That is called superposition. And you can say what is called entanglement. It means quantum bit can affect each other over huge distances. That is a huge correlation. So you have to work more towards statistically and mathematically in order to understand entanglement. But I will be covering one algorithm of machine learning, which will be possible with entanglement. Okay. So remember, if you talk of the today's word, which is matching, you can say quantum computing of the future, it is called parallel computing. So you can see if you talk of the quantum computing platform, we have the different types of particles that are given as input, and we can have different types of probabilities as the output. And that's the reason everybody, as of today, we have the highest, I don't say that it is the ready computer, but we can even say that more quantum qubit systems can be available. And I can even say that maybe in next 7 to 8 years, it will be like 9 qubit system. But right now, as making this presentation and doing some probable research, we have the 3 qubit system, which means at the same time, 3 types of states can be possible at the one single time. So you can say that the probabilities in front of you are there 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, or 1, 0, 0, or whatever the states that you can calculate. So you can say that at one time we were using the truth table with 4 states, but now we can have more than like 9 states at the same time. So you can say in terms of the quantum computer, we have taken the time factor of n bit number. You can say that we talk of the n bits. So as per the classical computers, we have the state of the art computers as compared to quantum computer. And of course, it offers a solution, because remember, at one time, Moore's law was to just change the technology after like 1 to 2 years. But today, Moore's law is contradicted, especially when we talk of artificial intelligence, because just chat GPT is now like 2 years and only 20 days old. But we can see that there is lots of things that are happening with the chat GPT and all those things. So remember everybody, when we talk of the advanced quantum computer, we are not talking of only simple type of bits. We are talking about the quantum bytes, which means it will be exponential based, you can say, computer. And that's the reason quantum computer will be having the remarkable amount of components and remarkable advanced speedy components that can make this computer like 700,000 times better than today's computer. So you can say if you talk of the history, it started from 1900 with Max Planck, and this is very important guideline for all of you, because 99% of the lectures they don't have. What is the problem, Mr. Shirka? Madam, I'm getting some problems with regard to what is the problem with the slide? Hello?
Yes, sir.
Madam, what is the problem with the slide? Are you able to see this?
Yeah, it is visible, sir.
But I don't know, but the people say that's why my continuity is breaking, please. Now I will ignore all the component. I will ignore all the things. Maybe the problem is that
Yeah,
there that you can,
I will check the messages, sir. You just ignore. Okay, sir.
But I don't know, madam, if you can see, I'm right now on fiber optics because right now my speed at my smart home is around what you can say 1 Gbps per second. So I don't say that there could be problem with regard to any packet manipulation. So I'm
Yes.
on the lease line. I'm working with fiber to the home because I'm in Vietnam. It is using optical communication network, which is the best network, I can say that. So
Yes.
everybody, we can come back to the lecture, but now I will not take any break. If there is any comment, I will ignore it. So the
Yes.
first thing everybody understand that if you talk of the foundation of quantum computing, it is actually way back 125 years, because now we are going to step up in the year 2025. So I will not take about 124 years. It is about 125 years when it started from 1900 in Max Planck, when we say that he was the actual originator of quantum theory. Now, I'm not talking of quantum dots or quantum thing. Quantum means that we can have the many number of states at one time when the calculation becomes too infinite. That is called the quantum state. So after that, there was an important concept of energy quantization, which means that energy cannot be stored today. Energy is unlimited. In fact, today, even if you ask me what is the actual capacity of the energy of sun, it is still in the quantum state. So if you talk of the size of the universe, it is still in the quantum state. It means the universe is expanding. And when we don't have the proper idea of the state, we say it is a quantum state. So 1905, I hope everybody know about the scientist Albert Einstein with photoelectric effect. 1913, Neil Bohr with atomic model, and he was the man which actually changed the science forever. After that, we have the 1924 with wave particle duality, 1926 with Erwin with wave mechanics, which means probability for possible results measured on the system. Remember, everybody understand today, if you talk of artificial intelligence, if I say you that this is the data set and we will getting more and more data, measure the accuracy of the system. So remember, there is a particular possibility that with machine learning, you can measure this time of accuracy, and we can even enhance the accuracy with more number of trainings and epochs. So the main thing is how is the capacity of your machine and what kind of measurement in terms of parameters you can measure. That's the answer. That is why we can say that that quantum computing is all about probabilities of measurement. So 1927, we have the uncertainty principle. Some properties of quantum object cannot be exactly known at the same time. That's the reason I'm telling you that what you don't know exactly at the same time, it all goes to quantum leap. And I hope everybody has seen that movie, The Ant-Man. If you have not seen that, please go to that. So in that, there is a concept of quantum realm. So go to search over there where time and space makes no sense. After that, the quantum realm actually starts. So in 1935, you can see that we talk of the thought experiment. You can say the Schrodinger's cat experiment, which we have the quantum superposition. So superposition means that quantum object can be in more than one state at one time, and entanglement means quantum object can affect each other over a long distance. And that was the most important experiment that you can have. So remember, everybody, if you talk of 1935, when Albert Einstein, Podolsky, and Rosen, they came together, this was the experiment that actually laid the foundation of particles and quantum mechanics, that is known as the EPR paradox. So you can say unless measuring on one particle, it instantly affects the other to prevent its accuracy, and meaning that information is transmitted faster than the light, which opposes the theory of relativity. So that's the reason, everybody. What do you mean by entanglement? That today, if you have a theory, we have to challenge the theory and we have to keep the measurement, keep on going, and we can see that there is a probable state and we can keep on improving that. So you can see in terms of this chart, 1970, when Charles Bennett and Stephen Wizner, they came to say, and you can say that 1980, this was the man. In fact, nobody knows about this person. He, according to me, after Alan Turing, this man should be given the father of quantum computer, or you can say the father of extreme futuristic computers, Mr. Yuri Manin. He actually proposed the idea of quantum computer in 1980. So you can say that quantum computer is not new today. It is around about, it was theoretically founded in 65 years before. And after that, everybody, we all know about the scientist. If you're a science student and if you have done your engineering in BTech and MTech carefully, so you have seen this man that is called the Richard Feynman with nature isn't classical, damn it. And if you want to make a simulation of nature, you would better make a quantum mechanical. And that's the reason it will be a wonderful problem. So even today, if you ask me that, sir, what is the accuracy that ants are able to find the probable food in a particular area? So that is also called quantum leap. In fact, if you say that honeybees go around and they find the distance and they find the, you can say the quantity of the flowers over there and the quantity of honey, they go and do the waggle dance and they can find the quantum realm, that what exactly will be the measurement of there. So remember, everybody, if you talk of the nature also, all the animals, all the insects are actually doing the measurement, they're doing entanglement, and they're doing superpositions in order to maintain the accuracy of their hives. So you can see this was the first paper, everybody. In fact, this presentation, I hope you are enjoying. This is very, very rare presentation and very beautiful presentation I've created. In fact, it took me about 13, 14 days to make this presentation. So you can say that when you talk of the quantum mechanics, 1984, Charles Bennett and Gilles Persad. In fact, these are the two people who actually proposed the cryptography based on quantum mechanics. Today, which we talk of elliptic curve cryptography, or you can say quantum cryptography. So quantum cryptography is still there. So quantum means that actually we can measure the states of security at one important time, and we can measure that how much it can be crackable, what cannot be crackable, and how we can improve that the hackers will be away from this type of quantum cryptography. So remember, what is the quantum cryptography? It means it will be having number of states. At the same time, we will be doing the measurement. We will keep on doing the measurements. We keep on improving. So remember, everybody, what is quantum? The state is not known. It is infinite state. That is the foundation. So you can say in 1985, David Detch, he described the universal quantum computer, and this is a very beautiful paper. In fact, today, this paper almost, I don't know how many citations it have. In fact, this paper should be given the Turing Award, or you can say the Nobel Prize. We all know that artificial neural network has got the that is called your Nobel Prize this year, but I'm expecting in next 5 to 6 years, maybe not next year or maybe next to next year, I'm expecting that once quantum computer will be released and the first working prototype real-time AI application will start working, then of course we will open the doors for a quantum computer to get the Nobel Prize, because it is physics. So everybody, you can understand, if you talk of the 1985 with David Detch, he was the man, he actually made the first paper, Quantum Theory, the Church-Turing Principle, and the Universal Quantum Computer. And this is very important paper if you really want to know about the quantum theory, quantum realm, quantum dots, quantum parallelism, and of course, that is called the fusion of complexity with the knowledge. So it's not a easy paper. In fact, you can say it has taken the limits of Turing machine to the next level. So you can say, if you talk of the 1993, then Charles Bennett and his team, they have the key knowledge about the quantum algorithm. So 1993, we started with quantum algorithms. And if you talk of the first quantum machine learning algorithm, it started in 2019. In fact, this algorithm is not very new. It is a little bit old, but still it is working. And after that, I hope if you are working on quantum algorithm, in fact, I will not tell you about the secret project I'm working. So if you are working on any quantum computing book, if you have read any quantum computing book, then these Shor and Grover algorithms are the first algorithms that you will be doing. So remember, everybody, if you talk of, remember, so what is a Shor algorithm? It is actually finding the possibility of factoring the number. So remember, everybody, if I say you represent 5 in different variations, you can say that 5 plus 0, 1 plus 4, we can even do the factorial or other things. So which means the Shor algorithm is actually finding how computer is becoming fundamentally better, how computer is finding the ways to solve this problem. In fact, remember, everybody, today, if you talk of Tower of Hanoi, at one time, we used to say that this problem is used to take about 32 years to solve the problem. But today with ChatGPT, we can solve this problem in less than 16 minutes. In fact, the traveling salesman problem has been solved. The Hamiltonian cycle problems has been solved. The QD factorial problem has already been solved. In fact, the biggest answer, the biggest myth of the problem, that what came first, the hen or the egg? Who came first? In fact, the answer today is called that the hen came first. It was not the egg. It all got the factorial and the measurement, and we are able to derive the answer. And of course, if you talk of the Grover's database, it was actually based on database indexing search, because tomorrow big data is so much big, we need to index the data so that we can be able to fetch the results. And that's the reason that today's Grover algorithm is actually there. It is going to be the future algorithm, because today, if you talk of the two algorithm, because I'm a computer hacker, so I'm a professional hacker. So right now, if you want to crack a password or anything, if you want me that, sir, please crack my computer's password or my email password or any network password, we have two types of techniques. One is brute force and one is dictionary. So if you talk of the next technique that we are working, and in fact, I'm also designing a software as a part of one of the open source team from Kali and Ubuntu Linux, we will be using the Grover, that is called the Grover codes. So that will be making the quantum based combinations. Today, if you talk of brute force, it makes a limited combinations of 4 to 5 characters, 7 to 8 characters, and after that it is gone. But let us talk about quantum based characters, which means that at one time, when brute force is attacking like 7 to 8 passwords with grooves force, we can calculate, we are doing like 179 or 300 possible measurements, entanglement and superpositions that we can crack the code. So the main thing is we are reducing the time and we are improving the time to crack that password. And that's the reason, everybody, 1996 with the D Benzino, He was the man who actually get for the implementation of quantum computer. So a scalable physical system. In fact, he was the man that is still working with Google. And of course, he is the man behind the Google quantum leap computer. So you can say, everybody, you can say that this is actually the first working prototype in front of you. In fact, I have done lots of research in this area about the finding the super dots. Very difficult to make this presentation. So you can say in 2004, Robert Skelp and Michael Devereux, I'm sorry for the pronunciation, they invented circuit quantum electrodynamic, because if you want of the electronic circuits, it all that says about the binary and the computer system architecture. But if you talk of the communication between the computers, it is actually between circuit quantum electrodynamic. This is the answer, that how these super qubits will be read. So if you talk of the binary digit, we can say 101010111111. These type of combination go. But in terms of the quantum communication, we need electrodynamic. And after that, everybody, we can say that IBM adopted this concept. At first time, it was IBM. In fact, let me tell you, if some people say that, sir, is the Google the first player? No. If many people don't know about it, but because we all say that Nokia invented the first phone, some people say about it, but it is wrong. Motorola was there. In fact, after Motorola, it was not even Nokia. Nokia was number 3. Number 2 was Ericsson. And if Motorola and Ericsson were not there, Nokia was not there. So remember, actually, the quantum computing foundation was not done by any company. It was not from industry. It was basically a theoretical concept which was originated from mathematics, physics, and of course, astrophysics. Nobody talks about astrophysics, but I will talk today. So it's a combination of astrophysics, physics, and of course with the electronics and electrical engineering, and of course with mathematics and core physics, you can say. But today, IBM was the first member that actually laid the foundation. They started with some concept, but after that, Google has taken the concept to the next level. And that's the reason, everybody, if you talk of 2016, IBM made quantum computer that was available on the cloud. But nobody knows who has accessed that computer. Even today, it is available or not. But trust me, IBM made the first quantum computer that was readily accessible on the cloud, but today we don't have any information much. In fact, it's a secret information that I've declared today. Now I will be discussing today of the modern technology. So you can say, if you talk of the qubit platform technology, so remember, I'm not talking of binary digits today. We are not talking of bit today. If you want to start with quantum computing, we have to study with qubit, then with your superposition, entanglement. Then we have to go to Shor algorithm, Groover algorithm, and then you are ready to understand the quantum circuits. So remember, we are talking about the advanced neutral atoms. Advanced neutral atom. No, I'm not a physicist. I never studied physics. I was like a +2 mathematics scholar with commerce. So I will not discuss more about the physics. So I'm not interested in that, but I will be telling you more about the diagram. But this is the best information I can give it to you. So remember, everybody, if you talk of the qubit platform technology, we have the main components called the trapped ions, neutral atoms, quantum dots, spin of phosphorus donors in SiP. I will not explain you that because I don't know. Nitrogen vacancy ion diamond, and of course superconducting circuits to trap ions. And that's the reason, everybody, if you talk of the chemicals, IBM used niobium and aluminum on Si wafer based on Josephson junction. Now this element is actually the primary element, that how this quantum computer will actually connect all the dots, and how this classical computer or the today's modern computers can be transformed to the quantum dots. So these are the quantum dots, and you can see this is the first diagram. In fact, this diagram has taken me about like 3 hours to find on the internet, and then I have decided to put this one. And it's a very secret website, you can see, but I will give you this presentation, no problem. So you can say that we have the electron and it is touching the gold. That's why you can say that if you talk of the most reactive chemical in quantum computing, it will be gold. And that's the reason, if you talk of the modern quantum computing by Google, it is all made from the gold particles. So you can say this is NV in diamond. And if you talk of the Gartner, everybody, as of 2023, I'm not talking about 2024 because I've not updated the presentation, because still we have 20 days. So quantum computing is still at the start. I don't say that it is going to be the topmost, still it will rule the world. But remember, if you want to make the quantum computing here, we still have to wait for 9 to 10 more years when the quantum computer is actually possible in the hands of the common man. So you can say as of 2027, we can expect that quantum computing will be coming up here. And it will be correlated with the different types of sciences like brain-computer interface, digital, twins, smart cities, serverless computing, and of course, maybe in the future when we talk of the biggest, you can say like a network called 6G communications or 6.5G communications, when we have integrated holograms and smart cities with autonomous vehicles, then of course, in order to bridge up this computing, in order to match the complexity computations, then quantum computer will be reliable, that this will be handled exactly not by today's modern computers or high performance a GPU based computers to accelerate the computing at a scalable of 10.5, but we need the quantum algorithm, quantum computers that can accelerate the computing in terms of exponential level. So you can say in terms of time between 2023 to 2033, in 5 to 10 years, that's the reason that quantum computing is still going to rise, but it is not going to be the top technology. Still, we understand that still 2033 is a very big time. We are going to enter 2025. Still, I'm expecting that in next 10 years, I don't see much improvement will be happening for the real-time persons, but the industry will be progressing one by one. So these are the top 10 strategy technology for 2024. You can say in terms of intelligence, we have autonomous things. We have augmented analytics that is called the data science. AI-driven development. I hope everybody knows that today AI tools are booming like anything, but I will not deliver the lecture of AI today, but I will share one link with you at the end of my lecture. You can just open. I'm making my own repository with the tools that we update right now. 7,000 tools we have gathered, so I will give it to you. So in terms of digital, we have digital twin, empowered edge. This is where I'm working, and immersive experience in terms of AR and VR. But of course, I don't see this future because I hope you have seen the news. Microsoft HoloLens 2 is already done. They have just updating the things for the next 2 years. That's all. No HoloLens 3. Secondly, you will be stunned to know, I don't know how many of you know about this or not. Apple Vision Pro came in 2024, and Apple has announced on 21st of November 2024 that there will be no Apple Vision Pro 2, which means immersive reality or augmented reality or virtual reality is now a flop technology. But the main center point of attraction for next 3 and 4 years will be quantum computing. So these are some of the events that you can see in terms of the flagships. When we have the European is actually, they are actually, no doubt India is also going to deliver some quantum computing solutions, but we know it is India. We can't promise that what can happen and what can be channelized. We need more skilled people in that. So you can say that if you talk of October 29 as of today, 1 billion euros and 10-year initiative is done by the European quantum flagship. In terms, we have the quantum communication, quantum computing, simulation, metrology and sensing, and basic sciences. And you can see the top projects. And you will be happy to know I'm one of the person who has already applied for one of the project for quantum simulation. So I'm not into quantum like circuits or basic like physics and chemistry or other things like that. I'm into quantum simulation, which I will be telling you some of the simulators where I'm contributing with one of the team from open source areas. So this is what you can say in terms of the quantum computers. We can still have the next 10 years, we can even expect quantum processors will be like 50 qubits. And of course, in 6 years, we can expect robust qubits. And in 10 years, we can even expect like 8 to 30 or even say 100 qubits, like all those things. And this is what you can say in terms of milestone, where University of Geneva, you can just go to online. They have already made the quantum computing that is called your dioelectric capable for autonomous operations. But remember, in next 3 years and 6 years, they are actually going to develop autonomous metro areas where everything will be autonomously controlled. And for controlling that particular thing, we need extensive amount of communication in milliseconds. And for that milliseconds, they are making their own quantum internet. Now, remember, everybody, nobody knows about this word. In fact, you can search on this word. No publication is still there. I'm 100% sure that right now you have listened to this word for the first time, that Internet 1 was basically with web pages. Now we have web 2.0, web 3.0 is like your full stack development. But the future is not your simple internet or web 4.0, web 5.0. It will be quantum internet, which means it will be having like a long range communication entangled based network, and SDN and NDN will be the foundation members in order to construct this type of quantum internet. So in terms of the future, you can say that in Paris, if you talk of the European nation, Paris is actually going for the quantum nation and quantum future, and they are investing about 3.3 billion US dollars. And this is the future of secure communications. You can see this website, cats-quantum.com. And this is from the UK University of Bristol. My friend is there. He is working with this laboratory. And I just had a talk with him. He wished me all the best today. In fact, in the future, if Madam needs, I can even invite him for as a keynote speaker for your university. So in fact, they are working to partner with two communication airlines that they want to make a complete airlines that can be even controlled, complete autonomous with only like 3 and 4 people. That is Airbus and Aqua. So Agile Quantum Safe Communication project is there. And within the next 2 years, they can even make their QKD and RNG based devices. So projects are going on, but these projects, I don't know when this type of projects we can enter or entertain with India or maybe the other Asian countries, but still right now, European Union and US are the top leaders and they will be the leaders. And this is the Q Insight, which is known as securing the hyper-connected society. This is one of the intelligent projects in the whole world. And this is China, everybody. And you can see this is a very rare photo I've produced in front of you. And you can say that if you talk of 2016, they launched the first quantum satellite. Now, I hope India has lots of private companies. They are also launching the nano satellite. Why not quantum satellite? So you can say it was completed over a 2,000-kilometer fiber optic backbone, new record of developing quantum radar. So remember everybody that the future of today, quantum internet is not only quantum computing, will be quantum internet, quantum radar, quantum satellites, quantum radio, quantum mobile communications. I can give a few terms like anything. And this is Australia, everybody, where my friend is there. He is the joint director for this Center for Quantum Computing and Communication Technology. And we are working day and night to produce one project for Australian Research Council for $18.75 billion. We are working day and night with more than like 75 scientists. I'm one of them. And we are working a lot in terms of the IoT based, like quantum IoT, that how we can integrate a complete quantum IoT of the entire city, and we can monitor the sensors and we can perform the measurements and we can perform advanced analytics on the cloud and we can perform the results. Now imagine what I can do for smart farming 7.0. Today, smart farming is at 3.0. I'm not imagining 4 or 5, I'm imagining 7.0. So that's the project. That's the thinking that you have to understand. So this is about one website called Quint Essential Lab, where enable encryption everywhere. And these are the people that are actually working for QCryptKey. In fact, today I'm not in my lab right now. In fact, one company, I will not tell you the name of the company, they have actually given me the key because my lab is having lots of data. We have the NAS also. So I just lock my NAS. And in fact, the key combination is based on quantum key cryptography. So we are working practically for cybersecurity in real time. And this is Silicon Quantum Computing Dawns. There you can see the website sqc.com.au, but I will give you this website, don't worry. And of course, USA, no need to tell you, President Trump has already given the National Quantum Computing Act. In fact, President Trump is signing lots of orders. In fact, he wants to go for quantum information sciences, which is actually made for storage, transmission, manipulation, and measurement of information, that how we can challenge the law of quantum physics. Now, Elon Musk is there. He's challenging himself. He's making quantum laws. And of course, quantum physics is there. But remember, we can even have the quantum blockchain and quantum crypto in the near future. This is where we are working in a very depth manner. So whatever the technology that you see today, we are working and we are trying our level best that we can define and coin those words, especially with some theoretical architecture and some proposed methodologies and what can be the integrated key terms that we can attract the researchers that we can work on this area. So this is the quantum image sensor, everybody, that in 2004, the idea was conceived. And in 2008, research began at Samsung Korea, where I visited. And 2011, research began at Dartmouth, supported by Rambus Incorporation. But the possible application right now that we're working is cryptography. In fact, all my friends from US, UK, Australia, and China, we are all working on cryptography only. We are working on hardware-based crypto devices. In fact, we are also working that how we can harden the next level of fingerprint and Face ID. Rather than to remove this, we can have some quantum cryptographic based encryption and we can make our mobile devices unhackable. So this is where I'm very much interested, because as a hacker, we have to make some provision even today that how we cannot get our devices or wearable technology not to be hacked. So this is Intel, everybody, with a 49 qubit processor. And this is one of the foundational thing that has happened in 2024, in July 2024. This was where 49 qubit processor is there, but still we don't have the much capacity to make it as a fully fledged quantum computer, because yesterday Google has launched their own quantum computer based processor. You have to see how many qubits. And this is IBM Q, the first working prototype. And we still don't know when it was used. After that, we have seen Google quantum computer, which is you can see in front of you right now. So this is classical computer where we have microwaves and signal getting, but over there we have the high bit connection room temperature, small virus crossing the temperature gradient. And that's the reason that the temperature and the cryogenic technology is very important for the quantum computer. And you can see this is the one very rare photograph in front of you that is called the IBM Q System 1. Now, many people don't know that IBM is one of the company that is working secretly, but still most of the things that is happening with IBM is completely hidden. In fact, I was talking to one of my friends from Australian Quantum Computing Research Center. We are writing one paper also. I will be telling you the journal which in which we are targeting, because the editor-in-chief is my friend. So if anybody wants to collaborate, they can collaborate. So I asked him that, are you in touch with IBM? He said, we know the people from IBM, but still IBM is like a hidden gem, and they are not interested to leak out any information. In fact, they don't publish white papers, they don't publish any papers, but still the insider news is that IBM is working something secret for space wave communication. It's an insider information, but I don't know how much it is correct or not, but IBM is jointly working with AT&T Labs for the futuristic mobile communication network. Now, if we assume that it is like a ground control communication network, already it is so advanced. Now imagine if it is working like that. Now imagine if we can have the potential of Starlink, complete like a satellite based internet at our home, if everything goes well. And this is what you can say in terms of the simulator, and this is the where we are working, that is the QIS kit. But I will be giving you some more simulators, and all the coding that you can see right now is based on Python. So if you have the Google Colab, if you can copy paste some of the codings over there, you can manipulate some of these circuits. But right now you can only work with quantum circuits, and that will be all. And this is the D-Wave technology where IBM is working. And if you ask me, this is the website that everybody can note right now, and you can open the dwavesys.com. And this is one of the, you can say, one of the best platform that you can see the software tools, the demonstration resources, real-time access to quantum hardware. You can see that, but still you need to have lots of money in order to do that, because if you want to have a quantum access, then you just have a free time of only 10 minutes. But after that, you have to pay like $2,000 per month. So you can understand that it is like a non-touching technology. And this is Google AI, everybody. And this you can see the very rare photo in front of you, the Google Quantum Bit Computer. In fact, this photograph was done like 25 days before. This is a very rare photograph I got from my friend in Google. And you can see it's a code name Bristol. And this is the answer that if you ask me that, like if you talk of the Google, like Intel processor, like Meteor Lake, or like i5, i9 processors, or even you can say the Ultra 9 processors. So Google Quantum Computer is based on Bristol Cone, and it is having 72 qubits. But of course, the race is towards more and more qubits. So that's the answer. 72 qubits is still very good, but I'm expecting that with next 2 and 3 years, when we can have the double the capacity with 150 to 250 qubits. But that is again my dream to see that computer. But of course, if you want to go for more cable, like more connectivity, we have to stress only on the high-speed optical fiber communications. And this is the answer, Microsoft, everybody. I hope everybody knows about Microsoft, and Microsoft is there with the quantum realm, and they are working on their own language called the Q#. Nobody knows about this, but Q# is a language that is actually based for quantum computing based programming, and it is still can be downloaded on Visual Studio platform, and you can see, but it is inspired from Java and Python together. And this is what you can say, one of the companies in Rigetti, and raised over 119 million US dollars. And they are working on something with regard to quantum programming in Python. And they also have their own Forest SDK. But their dream is to make a quantum computer for cancer-based generation, DNA sequencing, and all those things. So they are only working for hospital and healthcare-oriented applications. And I just come to the last part. So this is a very important website for all of you. If you really want to understand more about quantum computers designed to scalable to next heights, then you can say this is the website called quantumcircuits.com. Very beautiful website. And if you really want to see that what are the publications that are happening, what exactly are the next level stories that we can happen, but I will give you one website, but quantumcircuits.com is one of the beautiful websites where we open like 2-3 times a day, and we can even sign to the newsletters also. And this is the quantum computing research.html from New York Times. And this is the first workable theoretical computer at University of Dartmouth. So the question stands, everybody, will it practically work? The question again, if you can see the history, still all the concepts are from theory, but it is getting some highlights in terms of measurement, superposition, and entanglement. But the main thing is that we have to concern about the more number of qubits. So 1 times 49, then 72, we started from 3. We have the 49, we have 72, but we can expect for 300 to 400 qubits also. And that's the answer, everybody. If you talk of classical computer, the gate errors are 10 raised to power minus 22%, but in quantum computer, it is 0.1%, which means that the error rate reduction is like almost like a more than a sky and earth difference. So that's the answer that you have. The more important thing of quantum computer is that errors are almost gone and qubits are added and error rate decreases. And this is the answer, everybody, that many works will be related to hardware, software, and algorithms, plus funding supports in order to make a first useful quantum computer. But if anybody asks me that which company is making the quantum computer, it is only Google, but still IBM is like a closed sector. So with this, everybody, I finished my presentation number 1. Now we can have a break for 2 minutes. And after that, if you have any question, I will give you the time for 2 minutes. And after that, we will start with the PPT number 2. Thank you. Any question, please let me know within 1 minute. Excuse me, Shilpa ma'am.
Yes, sir.
Madam, 1 minute break, and then I will take some questions for 5 minutes, and then we go to PPT number 2.
Yes, sir. Sure.
Yeah, I just want to have some water. Thank you.
Okay. Participants can ask the questions in the chat.
Okay, so I can take some questions from the participants. Okay, thank you, Ms. Manjula, for appreciating the things. But I and my God knows, you can see the quality of the presentations, that how I managed these presentations apart from my busy schedule. In fact, my schedule is overloaded. In fact, getting all this history, compiling all this information, and getting the shape of this type of presentation is absolutely impossible. And I did my best of the classwork that you will see in the next of my 2 presentations. Okay. Any question, or anybody wants to interact with me or ask me any question with regard to qubits or something with regard to research? Most important. So quantum entanglement, you can say that if we want to measure that what is the capacity of internet today, if you talk of the internet, it is also like a quantum leap. We don't know how many websites are there, but the main thing is that tomorrow, if you want to search for anything or any information, it will be better than Google. And of course, there will be millions of states that will be working that even if today one website is getting updated, it will be giving you the better and better information. So that's the reason quantum internet is not going to be the internet which is only at the present state. In fact, the quantum internet will be the state which is actually expanding every and every second, each and every second. That's the reason entanglement is there. We have to measure, we have to keep on accessing with the possibility of limits. That is called entanglement. I hope concepts are getting clear today with this presentation of mine.
Yes,
Shilpa ma'am,
sir.
I hope concepts are getting clear.
Yes, sir.
Yes. Any other question, everybody? You are getting the chance. Okay, so what are the other many possible states we can have in here? So I have already told you that what is called superposition. Superposition means that we have as many number of states. Now imagine everybody, like suppose that I'm a gamer, okay, and I want to test one game, like suppose like Black Myth Wukong, or suppose if I take a very popular game called Forza or Need for Speed. Now, what is the rate of the like FPS for my particular computer? It can say that with this type of A settings, we can have like 137 frames per second. Now, with quantum computer, I can connect these computers and I can see that what kind of possible computer combinations are there and what is the best possible combination that the game is giving the best possible state. So which means I have to test and retest. Same is called the DNA sequencing, that what could be the best sequencing. In fact, let me tell you, one is the answer. In fact, I don't know how many people know about it or not. I don't remember the lab and the person. You just have to go. In fact, they have already covered this person in NAS Daily. So please go to YouTube and go to NAS Daily. In fact, there is a lab in US. One lab, I don't know whether it is in US or UK or Europe. I don't know, but you can just search simulation of a human body. In fact, they have done a particular simulation of a human body that suppose today, if a body has a COVID-19, they will simulate the COVID-19 in that body. And the other companies like I am working or Shilpa ma'am is working or Sridhar is working. So they have made medicine 1, 2, and 3. What will be the impact of that medicine? So for that, you have to go for millions of DNA sequencing, possibility of states that, okay, this medicine will be okay. It will control the COVID, but it can have malaria. This medicine is okay, but it can give you some type of jaundice. this medicine is okay, but no side effect. So how you will get it? So that's the other possible states that you can do. But in terms of healthcare, in terms of DNA sequencing, medical testing, medicine testing, this is the answer. Quantum computing has a huge leap in that area. You got it, Chandralekha, madam? I can give you 100 examples for quantum computing where we are actually working, where we are just like doing our knowledge study, but we are not publishing right now. We are not publishing. I will tell you why. In fact, you will agree with me that, sir, if we want to write a quantum computing paper, it's so much complex. It is so complex paper that, trust me, if you want to make a particular shape of the paper, it will take about 6 months, even if you have written the paper today. But the problem is, I will not get the reward. In fact, the reward will not be more than like 2.5 impact factor. So I will not invest my time and energy for today as if of next 2 years in order to waste my time for the quantum computing based publication. I will not try to waste it. Okay, one more question, everybody. I would like to take this then to the next level. Thank you. Anybody who wants to interact with me or unmute yourself, you are most welcome. So what are the limitations of quantum hardware? The only limitation is that still we can't test the complete quantum computer. The only thing is that the companies are only working on one thing, that increase the number of qubits. But how they have increased, what will be the possible real-time application, what will be the challenges that they are overcoming, this is impossible. In fact, we don't have a particular qubit. In fact, we don't have the particular platform that this quantum hardware is actually working to the full potential. That's the answer. We don't have the particular real-time application to understand the limits of quantum hardware. In fact, we just talk about quantum processor. We talk about quantum computer. We talk about superposition. We're talking about entanglement and measurement. But what about the giant leap towards improvements in the measurement control, getting the error reduction with some simulations and all those things? This is actually complicated. So that's the reason this is the limitation that we can't test it. Okay. So, ma'am, I hope everybody is enjoying. I hope so.
Yes, sir.
Okay. Thank you so much. Because actually my biggest worry was because I'm like a non-specialist person for quantum computing. In fact, even if you call many people, they can just prepare a presentation, but I learn from many things. In fact, I'm working with some of the teams and I'm trying my level best to prepare the best presentation for all of you. Okay, this is the best I can perform. Okay. So everybody, let us start with the second part of our lecture. That will be lecture number 2, presentation number 2. And don't worry, I will be giving you all the 3 presentations after this lecture to Shilpa ma'am. And Shilpa ma'am, I request you again, please deliver all these 3 presentations to the participants. Okay, no problems. So everybody, today, the most important thing, you have seen this person, Niels Bohr, which I have shown you the photo. In fact, the photo showing of this person is, in fact, the photos of all the scientists which I have produced. In fact, that 3 presentations have taken about 4 hours of mine. In fact, lots of time I have invested to make these 3 presentations for all of you. You can see my efforts right now. So everybody understand. So the main important thing is that there is no quantum world. There is no quantum world. There is only abstract physical description. In fact, many of the concepts, even today, they are actually under theoretical proposal. At one time, if I want to say that, sir, drones will be used to carry, there will be flying cars in 2007, many people will say me, sir, I think you should go for some CAT scan. Yeah, people will say that. But today we have those flying cars, we have those supercars, we have the drones that are working for military, they're working for farmers and everywhere. Okay. So remember, it is wrong to think that the task of physics is to find how the nature is. Physics concerns what we can say about the nature. That's the main $1 million answer for all of you. So everybody, quantum computing is modern magic and quantum machine learning turns that data into the magic. Now, remember everybody, what is machine learning? It means we are learning from the data without getting the machines programmed explicitly, which means we don't have to reprogram the machines. Now, imagine if you talk of the quantum computer, we are actually talking of the next level of gigabyte or yottabyte level of data. And for that particular learning task, we are using quantum machine learning. Now, imagine the future of quantum internet. Now, today, if you talk of internet today, we are using Chat GPT, we are using Google Lens and all those tools. Now, imagine if I have the quantum internet and I want to search some information, in fact, Chat GPT and all those engines, the models will be powered at the back end of quantum computer, and that will lead to the giant nap of the quantum internet. So today, everybody, I will be discussing very important power for all of you. In fact, the first photo for IBM's quantum computer is in front of you. Very difficult photo to find. In fact, this front page, everybody, it took me about 10 to 20 minutes to design this page itself. So I will be discussing quantum computing, quantum machine learning, concepts, applications, and major players. Now, if you want to ask me one question, that's sir, which software you have used to make these presentations? So let me tell you, I'm not using PowerPoint. PowerPoint is hated. I'm not using LaTeX also. LaTeX is also a very good tool to make the presentations. In fact, I'm using that is called your Canva. I'm using Canva to high-end thing, but becoming expert into Canva is not easy. And if in fact, I can give you some website of torrents, you can just download those torrents for Canva training. And there is separate training for Canva that how you can make these effective presentations. Okay, so I'm not using an old school technology of PowerPoint. I'm using the modern technology, digital technology that is called your Canva technology. So if you ask me that, sir, I want to give a powerful presentation, what is the answer for that? I want to make a powerful websites. I want to make a powerful diagram and all those things. We are actually working with Canva with its AI features, and then we are able to deliver these type of things. Okay. In fact, I will show you one or two diagrams. You will be happy to know that this is my first presentation. You can all clap for me if you want to clap. In fact, this is my first presentation in which you will not be able to distinguish that some of the images are actually generated from Midjourney. I'm the paid person from Midjourney. In fact, I generated those images from Midjourney with my prompts, which are actually like 20 to 30 lines of prompts. I will show you that image. You will be shocked to see. So everybody, let us first of all talk about quantum computing and quantum machine learning. Now, I'm not a physics person, so I will not discuss about physics, but you can discuss about physics in the future. So everybody, what is quantum mechanics? If you want to ask me that, sir, there is quantum computing. Quantum computing is a part. If you talk of the quantum, so it is called the quantum science. Quantum science has different parts called quantum mechanics, quantum chemistry, quantum physics. So in terms of quantum mechanics, you come down, there we have these quantum computing. So there is a quantum word, quantum mechanics, and under quantum mechanics, we have the quantum computing. In fact, if you want to derive this in the form of flowchart. So you can say that if you talk of quantum mechanics, it is known as a science to deal the behavior of matter and light on the atomic and subatomic scale. And if you talk of the old Britannica, I hope if you are a 90s kids, I was like a 90s kids, and I had fought with my father that I will top my 10th exam. I got 100 out of 100 marks in mathematics. And I fought with my father that if I get 100 out of 100 in mathematics, you have to buy Britannica for me. In fact, at that time, pirated CDs were very less. We have to buy the originality. And at that time, my father spent 4,000 rupees. And at that time, I got my Britannica for about like 8 CD-ROMs. And I hope everybody knows about those age-old of CD-ROMs and DVD-ROMs. I love that technology. So you can say if you talk of quantum mechanics, it's a foundation for quantum physics, including quantum chemistry, quantum field, quantum technology, and quantum information science. So remember again, everybody understand, I'm not talking about quantum computing right now. I'm talking about quantum, that is called the quantum science. It's a quantum science. Quantum science has different parts. And in that quantum science, we have one part called quantum mechanics, and quantum mechanics go to quantum computing, quantum computer, quantum machine learning, and all those things. So remember everybody, what is quantum machine learning? I will not go for quantum computation. You can see that. So remember everybody, what is quantum machine learning? It looks at opportunities that how these quantum computers will look into the data and how they will learn from that data, which will be in an exponential form of data, and how we can able to generate the results. Now imagine everybody today, let me ask you one question. Now, if suppose today I give you 1 million images of breast cancer, you can see my papers. In fact, I'm the first scientist in the whole planet that has a breast cancer based detection of 99.96%. I have my paper in that. And in fact, COVID detection of 98%. Maybe that was a highly cited paper. Both of the papers have got like more than 400 and 500 citations. In fact, the biggest machine learning paper, the highly cited machine learning paper, you can see it is having 1,000 citations. It belongs to me. So quantum machine learning. Now remember everybody, machine learning is all about data. Artificial intelligence is all about data. Data is the fuel. Data is called the new black gold. It's the black gold. So remember, today, if you talk of the breast cancer or any images, if you want to make some animation cartoons or something like that, like ChatGPT, you have to train with billions of images. Now imagine, I'm not talking of billions of images. I'm talking of the entire internet. entire internet, which is even evolving as of 5 seconds before, that is quantum internet. And those quantum machine learning algorithms are learning from that data at a response of milliseconds and giving you the response. That's the answer, everybody. What is quantum machine learning? Which means the machine learning algorithms are never at rest. Data will be generated. Data will be generated at exobytes or even like yottabytes, and it is getting formulated under the model and giving the results at the same time as it happens. And that's the reason, everybody, if you talk of the quantum computers, now that's my answer. You can see this is called the highest nodes. Now you can see how I make my presentations, the notes for you. They are much faster. They can break the passwords. That's the reason if you talk of the biggest application for quantum computer for hackers is that today even the AES 512-bit, or even you can say if you talk of the RSA algorithm or SHA-2 algorithm, they are not breakable. So with quantum computer, they can break. In fact, they will work entirely different from the principles of your qubits 1 and 0 at the same time. They can run programs. They use virtually no electricity. In fact, they will be energy efficient, and they will soon replace our laptops. But it is still a theory, and still we need to invest the biggest amount of dollars in the near future. But the question stands, it is a risk. Today, if suppose I am a billionaire businessman, like I am like a Dhirubhai Ambani, and if any company comes to me that, sir, we have this type of theory, we have this type of application, we need like 75 crore rupees from you. Trust me, I have to think 30 times more before I give the funding to them. Still, it is a theory. So these are some of the quantum machines that you can see, quantum technologies in terms of quantum sensing instruments. Okay. So remember, today, if you talk of now, imagine everybody today, if doctors gives you that, okay, sir, you are sick, go to the hospital, get your blood test, get your urine test, get your CT scan, and get everything. Now imagine everybody, I'm just on a bed, and one machine comes to me, and immediately within 5 minutes, that machine takes my entire 20 tests and give the report in 10 seconds with the recommendations like explainable. Now imagine what will be the sensing, what will be the future of treatment. Imagine a soldier is dying, and if you want to operate from a bullet, it will take like 30 to 40 minutes and soldier can die. Imagine a bullet can be taken out in less than 20 microseconds. Imagine the machines. Quantum information systems like quantum cryptography, quantum computers, quantum inspired system that will be based on swarm intelligence. And that's the answer, everybody. If you talk of quantum computers, we have the high performance computers, quantum annealing computers, quantum circuits, universal quantum computers. In fact, even today, everybody, I hope, I'm sure that you are learning these words right now. Quantum annealing computers and topological quantum computers. In fact, there is no standard definition for these. In fact, there is no definition for quantum Turing machine also. No definition. I challenge about it. I challenge. In fact, I know lots of things are there on Wikipedia, but that is just an opinion. That is not a definition. Remember, there is a difference between two things. Opinion means that a person is giving an opinion that it might be connected to this concept. This is called opinion. Definition means when we have proper keywords, when we have proper shots, when we have proper terminologies, and everything is making sense from the top to the end, that it is the consistent definition which defines the thing, that is called definition. So still, Nate, there is no definition for these three terminologies. I doubt about it. So if you want to learn about quantum computing, so remember, you have to learn about quantum mechanics, which consists of your mathematics, complex numbers, linear algebra, probability, and statistics. Now, I'm a statistician, I'm a mathematician. I'm not like a mathematician, but I'm like a math-based oriented person. So that's the reason we work on these type of theoretical things. And of course, if you want to learn for quantum machine learning, then only data science, calculus, and machine learning. So that's the answer. If you are good into machine learning, you know this type of data. We have SVMs, we have linear regression, we have random forest. We can work on deep learning based CNN, KNNs, and all those things which I will be showing you. You can work beautifully into quantum machine learning. So these are some of the initiatives, and still you can see, everybody, that India is having So right now the lowest investment is from India only. That is with $1 billion by the government. So I'm not going to going for like a debate over that, but still $1 billion. What is the perspective? What exactly we are planning to perform? What will be funded, and who will be funded, and what organizations will be funded, and what kind of prerequisites are there? But trust me, it is still unknown to this information. So these are the major players that you can see right now. This is the very important thing that you should understand. So as of 2023, so sorry, I didn't replace it, but I will replace it for you. So IBM, Google, Rigetti, these are the three companies. Nobody knows about it. In fact, if you talk of the simulators, everybody, if you talk of Amazon Web Services, Amazon is also making its simulator also. In fact, my friend is in Alibaba Cloud. I'm a Alibaba certified. They are working to collaborate with AWS and of course with Azure, and they can work on a combined simulator that will be based on cloud-based quantum simulator. And of course, if you talk of applications, NASA, Accenture, and OneQubit in terms of medical and finances there. Now imagine everybody, why it is finance? Because still, I hope everybody knows about the movie Scam, Harshad Mehta and all those things, the Big Bull and all those movies you have seen. The thing is, if you talk of the finance word, the matter is not about in seconds. It is not in microsecond, it is in milliseconds. Now remember that if the data came and you're fast in milliseconds, you are getting the first information, you are investing into the shares or you're shorting up the shares. I'm sorry. So remember, you can earn billions of dollars. And that's the reason everybody, if you talk of the software, IBM, Google, and Microsoft Azure Quantum, these are there. But trust me, all these softwares are paid softwares. Now I will go to the in-depth, everybody. What are the fundamental concepts with regard to quantum machine learning before we go to this presentation? Now I hope everybody know about the thing called qubit. Qubit means that we have a device representing a unit of quantum information. It is in superposition. Superposition means many states where alpha and beta are complex numbers and we have probability amplitudes. And that's the reason the qubit state can be defined by 4 numbers. Alpha and beta are real, imaginary, and we can have the 3D degree of freedom. That's the reason I have made this diagram. And that's the reason if you talk of quantum state, it is also like a circle that we can have tons of number of vector states in terms of x, y, and z axis. Today, if you talk of computers, we have x and y, but in terms of quantum bits, we have x, y, and z axis, and there will be infinite possible number of quantum bit states. And that's the reason everybody, if you measure them, we can have the probability of measured outcome that is still a not defined formula. So remember, measurement, I don't say that this is a particular measurement outcome, this is the end result. No, we still have to measure, and measure. Like we train the machines, we keep on training, we keep on updating the data like machine learning. And this is about multiple qubits, the entanglements. You can see when two qubits are independent, their measurements are also independent. And that's the reason everybody, if you talk of the changes to qubit states, we can be designed using quantum gates. Now, I'm not talking about AND gate, NOR gate, or your simple gates of CSA. I'm talking about quantum gates in which the qubits have to be designed. And that is what your simulators do. So you just have to define the states, you have to arrange the circuits, and in that circuits, you have to find the entanglement, that how these measurements are coming. And you can define in terms of your DNA sequencing, your data, your machine learning, different things. But still, only simulators are available for quantum circuits and quantum entanglement, with manipulations, just correlation based orientation. That's the reason publication is not regarded as novel publication. And this is the answer that you can see, one of the beautiful presentation slide in front of you, that we can make your own mathematical model with Python plus QIS kit, and you can see the circuit diagram. And you can see the foundation is based on C++ and Java. So I give you 10 seconds more to see this, and I will be giving you some of the simulators before I start with my third slide. So building a quantum solution, so you can say that we have the quantum registers, we have the preparation in terms of the input, and now input is exponential level, and we are processing in terms of the quantum gates that are actually having tons of entanglements, and we have the measurement in terms of output with a higher loss of, that is called the correlations. So these are some of the applications of quantum. Now it depends on you. If you want, I can discuss with you that what kind of review paper you can write, but I'm writing 2 review papers. One is on cybersecurity, and second, I'm writing on new chemicals and drugs. In fact, if you can just see my book, AI in Drug Design and Development, that has just been released by Wiley. In fact, now the second volume of this book will be based on quantum also. I'm working on 1 chapter. So if you want to go for cybersecurity, breaking the cyber codes, materials in terms of the batteries. In fact, today even we have the lithium ion battery, but we have to measure with different chemicals. Now imagine everybody now you can see one of the example. Now what is called quantum circuits and quantum entanglement? What is measurement? That today, if you have the nickel cadmium battery and lithium ion battery, we have to test different chemicals. We have to make different types of possible chemical compositions, and then we have to measure that what will be the state of the battery if we are working on motorbike or car or even your satellites. Now you have to measure, and then you have to find out that which is the most stable state of the ions, and what are the possible chemical compositions you can make that your next mobile phone battery cannot be used to even charge. Maybe if I buy the phone, there will be no charger. I don't have to charge my phone. We have to find the possible combinations. For that, we have to give the tons and tons of the data. We have to define the attributes and entities going for the quantum entanglement with the circuits. And then we have to define that what exactly will be the measurement and correlation. So that's the reason, everybody, if you talk of the precision instruments, imaging, so different entanglement and superposition states you can imagine in terms of your area. So if you talk of the QML to quantum model, this is the answer, everybody. If you talk of the preparation, this is called the training data set. Now, I'm not talking of the thousands of data or you can say millions of data. I'm talking of billions of data, which is actually in the quantum level, or you can say the exponential level, which is like the quantum internet. So after that, we have the optimization algorithm, which is processing the circuits. And after that, we have the measurements. Now, imagine, everybody, I can give you one problem like this. Imagine you are working as an electrical engineer, and right now you are working with Siemens, or you're working with a like an ABC battery company, and now they want to take the battery to the next level. They want new compositions to come so that the battery of mobile phone can be taken to giant leap of like 1 month without even charging your mobile phone. So you have to find the chemicals. Now for that finding of the chemical composition, you have to go for n number of states, n number of experimentations, n number of challenges you have to go. And that's how you can form this type of data as a data set of this type of chemicals. And then you can process those chemicals, and then you can have the output. But remember, the data I'm talking is not a simple data. It is a quantum data. It's a quantum data, and you can form those circuits. And because the state will not be one, it will be hundreds of states that you can go at the same time. That okay, at one time we are making some mercury and nickel. At second state, it is working with some 3-4 like ferrous oxide or aluminum oxide, sulfur dioxide or hydrogen chemical oxide. I'm not a chemistry man, but these type of chemistry I've learned in my schools. So that's the reason I don't have interest, but I'm giving you some of the examples. And then we can find out that in next like 4-5 months, what will be the chemical state that is posted as the highest chemical state, and that could be the future battery. So remember, this is called quantum machine learning. Tons of data, tons of processing, tons of optimization algorithms, and output will be defined. So these are some of the algorithms which I will be discussing, but not much, because these algorithms, I'm not specialized. I can just show you the algorithm. In fact, I made a beautiful presentation for all of you. And you can see those algorithms, they cannot be implemented right now. Yes, they cannot be implemented. They're all theoretical. They're all mathematical. In fact, if you ask me that, sir, is there any platform where we can define the quantum algorithm? Yes, you can define the quantum algorithm on Google Colab, but where you can get the data set with the quantum type of data set, it is impossible. That's the reason. So these are some of the risks associated, and that is my answer to all of you, that many people are asking me these questions, sir. What is the challenge of quantum computing? What is the benefits? What are the risks associated? What are the limitations that are associated? That is the answer. So you can see the way of presentation. Fact is, quantum computing suits the problem that are highly complex. Quantum machine learning can make the data rich. We can solve the problem, but the problem is that still we have the highest level of entry cost. Still, we don't have the particular hardware. We have the lack of knowledge and skills. We have shortage of expertise. We have shortage of development tools. And the highest problem is that still we don't know what would be the possible outcome. Because today, if you talk of the data of AI, but what is the possible outcome? How you will read that outcome? How you will be studying that outcome? How you will be validating that outcome? This is impossible. It is under development. So these are some of the opportunities are in front of you, and this is where we are working: AI and IoT and materials. So you can see, and cybersecurity also. So education is that I will be giving you some of the programs that you can study, but trust me, after this presentation, I'm going to blow your mind with lots of online websites and some simulation tools. Then I go to quantum machine learning. But trust me, if anybody say to you that, okay, I have implemented quantum machine learning in my computer, it's a bullshit. It is impossible. Okay, so you can see, everybody, in terms of resources, I will be exploring more. And some of the bibliography is in front of you, but you can study. But trust me, if you ask me that, sir, what is the first book that I should study? The first book is this one: Lorendo Robert, Learn Quantum Computing with Python and IBM Computing. In fact, I can tell you one website where you can download all the ebooks. Just wait for 1 minute. And after that, everybody, if you talk of the next book, it is called Quantum Computing and Quantum Information. That's my answer. So with this, I wind up my lecture number 2. And before I go to lecture number 3, I would like to share some practical resources for all of you so that I can answer that where you can go for the quantum code and where you can design some algorithm, but everything has its own limitation. So the first website of everything is everybody, the Quantum Insider. In fact, I've already given you the first slide. You can take that slide from Madam Shilpa. She will be giving you the slide and you can open all those websites. So if you want to understand what exactly is the quantum computing having, what are the quantum computing news, what are the featured articles, this is the best answer that you can see. In fact, right now, the businesses are actually going for the translation that how we can go for nanoscience. In fact, the scientists are actually improving the signals of chemical engineering up to 97%. But remember, this is all insider information. How they are doing and what they are doing, what is the code behind that, it is impossible to find. So the second website, everybody, it is the course that you should understand from MIT. This is Quantum Computing Fundamentals. Very important course, very beautiful course. I've already done this course, but this is actually called the revolution, but still 90% of the course is theoretical. They will just tell you about quantum circuits, IBM some deep learning based algorithms, what is the future, what is the base case studies and all those things. But still, it is a very beautiful course that you can do and it is free of cost. The third website that you can see is Career Vera and Dummy's Guide to Practical Quantum Computing with IBM Qiskit. So this is the answer that you can go, and it is only like a course of about $7. And you can see that still it is working with IBM Qiskit. So if you ask me that, sir, what is the first simulator or what is the like enriched simulator for quantum computing, it is IBM Qiskit, which I will be telling you after some time how to use it. So you can see over there. Now, everybody, let me go to some of the simulators. So the first simulator that is already with Google, it is with QSIM. So optimized quantum computing simulators, and you can just copy paste all this code and you can put this code exactly into Google Colab and you can just search over there. But remember, the still simulation is only up to 25 qubits, not up to like 70 or 49 qubits. So you can make some corrections in some circuits. So Google Quantum AI is one of the answer. That's the QSIM, and you can see that it is only optimized quantum circuit simulator based on C++. Still, it is not in Python. So remember, still, if you ask me that what is the primary language of quantum computing, it is C++. After that, it will be Python after 2 years. After that, everybody, this is the very important simulator which is available online. It is called the Alga. You can take the photo of my slide and you can see that if you want to make a gate, if you want to make some circuit gate, if you want to make an entanglement or measurement, this is the answer. So you can see I've already made one of the example in front of you, and you can see this measurement is coming is in front of you in terms of decimals. But still, it is very impossible to read because I'm not a physicist and I'm not a chemistry person. So you can see in terms of toolboxes, you can make the menu, you can edit the circuit, you can put all those things. You can see half turns, quarter turns, all this, everything. Okay. After that, everybody, if you ask me that what is the best, another Intel simulator, this is called the Intel QS. So if you can go for it, you can even build this quantum simulator with Ubuntu, and you can just git clone this. And if you have like Visual Studio Code installed, but we prefer to have like a 8 GB RAM virtual machine with Ubuntu, you can go for Intel based quantum simulator. And this one is another one that is called the Stack. You can take the photo. So Stack is another simulator, but I can give you 45, but still for limitation, I will not go for it. And everybody, this is the answer, everybody, that this is, if you really want to go for fast computing simulation, which is like a quantum bit and gate simulator only for the circuits, quantum circuits only, then this is the answer. That is a Qiskit. So again, this simulator is open source and still we can't trust the solutions because it is still based on X indexed LDAs. And this is the simulator, my personal favorite, where we are learning. And right now I'm working day and night to work on this simulator. It is called the QX simulator, quantum computing simulation. And even the future will be Quantum Studio. Like today we have the language model studio, Visual Studio Studio. So this is called the Quantum Studio, where you can even offer circuit rendering. So right now, if you see 90%, or you can say 95% of the simulators are only based on quantum circuits, only quantum circuits. And this is the answer. If you ask me that, sir, I want to go for some chemical based or something like a package for system dynamics or system simulation, the QSIM is the answer. But again, you have to go for installation properly. You can see the installation right now. I can show you. So you can see again, you need some proper Linux-based system in order to code that. And there is a tutorial here. You can even see the codes also. In fact, you can see what is the initial state, what is the level 1 potentials. And again, you can just go for some of these circuits only circuits, that's all. And now everybody, if you ask me that, sir, where we can publish our papers. Now, I would like to tell you that there are only 3 journals, But still, if you see, there is IIT Quantum Communication. I was the associate editor, but my term was finished because I was not able to find the reviewers. I only handled only 7 papers in 2022 and 8 papers in 2023. But my contract was terminated from 1st January 2024. So I was not there. So still you can see it is indexed only in ACM, Dodge, and even it is just like a basic Scopus, which is Q4, just got indexed. And we don't know that how much charges it is there, but it is waived right now in 2024 because they are not getting the papers, but from 2025 they will be putting about $1,600. So if you can make any research paper like a basic, like a review paper, this is the answer that you can get your first Scopus paper into quantum communication. This is the answer. And this is the journal, everybody. Nobody knows about it. In fact, it's a very confidential journal. This is the ACM transaction on quantum computing. So you can read some of the papers here, but most of the papers are actually based on quantum circuits only. So you can see model-driven framework for quantum circuit, again, quantum circuit simulation. So again, it is only based on quantum because quantum circuits can only be simulated, not any other. And the third journal, it is from Tech Science Press. I hope you know about this journal called Intelligent System and Automation. I have recently joined this journal as an associate editor for CMC, and they have also already offered me to join as a co-editor-in-chief. I'm happy to inform you. Maybe from February 2025, I will be the co-editor-in-chief of this journal, that of quantum computing. But still, we have to work more on indexing. You can see the indexing is right now in Portico. We are not getting even the Google Scholar indexing. Now, everybody, I would like to tell you something about the website. So you can go for this website called libgen.is. So you can go over here, and if you type over here, so here you can even search for any book over here, but if you search like quantum computing, so if you search like quantum, computing, you can see that 90% of the books and even the papers are available here. So you can read this book like Introduction to Quantum Computing. So if you want to download this book, like suppose if I want to download this book, just click on Introduction to Quantum Computing. That is from Philip L. And just click on this one called libgen.il. And after that, what you have to do is to just click on Get. Just click on Get, and you can see that the ebook will be getting downloaded. Maybe some network problem here. So you can see right now that the ebook is getting downloaded right now. Okay. So after it completes, it will be giving me the full book. And right now you can download all the books from like Elsevier, Springer, IJ Global, all those things. Okay. So with this, everybody, I would like to little bit take a break for 5 minutes. And after that, if you have any question right now, please let me know. Excuse me, Shilpa ma'am.
Yes, sir.
Excuse me, ma'am.
Yes, sir.
Yes, we will start after 5 minutes. Meanwhile, if anybody has any question, most welcome to interact with me. I hope this is the best I can give it to you.
Yes, sir. May I know how much more time it will take for the next session, sir?
Maybe third slide will take about 30 minutes.
30 minutes. Okay.
30 minutes. Because, madam, I already told you that if you really want me to give you the foundations, some extra knowledge and all those things, it's like I don't want to hurry. I just want to go slowly because quantum computing, I'm sure today many concepts of people are actually cleared from my lecture.
Yes, sir. Yes, sir. We are more than happy to have all the information. Actually, we are overwhelmed with this information. I mean, more than what we expected. You have been.
Ma'am, what the first thing is that, madam, today, you will be shocked to know that people can make the presentation, people can copy paste the data. That is not a problem today. The main thing today is how you acquire the data. The second thing is how quickly you present the data in a flow, and how is your presentation skill to present that data. That's my answer. That presentation making is like an art. In fact, you will be shocked to know, ma'am, that after 10 days, I'm giving one lecture in IIT Delhi. They have invited me that how to become an effective teacher and how to make the perfect presentation for undergraduate
I've been
and for the
following
master.
you, sir. Yeah, I've been following you.
Madam, in fact, I'm making one presentation that how to make an effective presentation for undergraduate and master students, and then for the PhD scholars. I'm making 3 presentations for that.
Okay.
Yeah, I'm making for that. In fact.
Those will be available on your YouTube and those, right? We can
Not
have.
for YouTube, madam, but not for YouTube, but actually I will be sharing. If you want, you can just message me in the first week of January that, sir,
Yeah.
can you give me some presentation so I can share that presentation? You can share with the group right now. No problem.
Okay, okay, sir.
Okay, so I'm getting one question that, sir, could you share all these URLs? I have already given you the website, so you can just see them, because right now I cannot share all the information. One thing you have to be aware with the lecture.
Yeah, yeah.
Okay,
Sure.
and there is a thing from Chandrakala again, sir. If we want to publish a Scopus paper on quantum ML, can you suggest a problem statement? The only problem statement is that, madam, you can write a review paper that what exactly is the foundations, and of course the you can say you can write a paper like this, that is a comprehensive analysis and review of quantum machine learning algorithms, uh, a, a bibliometric analysis. That is called the title that you can say. In fact, if you ask me, let me show you something. In fact, everybody can see this. Can you see my computer, madam? Can you see?
No, sir. Right now it is not sharing.
Okay. I'm just sharing. I will tell you how to use ChatGPT effectively. Just wait. Can you see the screen, madam?
Yes, sir.
Okay. So everybody, if you ask me that, sir, I want to buy ChatGPT, don't buy ChatGPT. In fact, I suggest you go to this website called monica.im, because today I'm not going for AI lecture, but in fact, Shilpa ma'am can arrange one AI lecture for me in the future about AI tools, practical lecture. So you can go for Monica and you can just pay $50 and you can get all the access to, you can see all the models. Okay. Now you can see how I will take the ChatGPT. Now see this. Now see, you are an excellent researcher and scientist in quantum computing and quantum mechanics. Now note down this, everybody. Take the photo once I'm done. Okay. So I want to write a review paper on quantum machine learning, covering the basics to advanced level. Now see what I'm going to show you. Draft a creative title for me, which is super novel, and also enlist the components of research paper. I want to keep the research paper up to 8,000 to 18,000 words. Now see the results, everybody. Got the paper, madam? Got the paper, everybody? How we can design our chapters, how we can design what exactly should be the components of the paper. You can see right now, components will be abstract, and you can see a beautiful title has come to me: Quantum Machine Learning, Bridging the Quantum Realm with Classical Intelligence. Wow, what a beautiful title. So even you can redraft this title, you can do like this: background, and you can see quantum machine learning algorithms, key concepts, application, challenges and limitations, future directions, and conclusion. Okay, and you can see right now, even it has given me the suggestions, what exactly should be performed. This is how, everybody, we actually tell ChatGPT to make a structure for us. Okay. So Shilpa ma'am, my offer is open for you, that if in the future you are planning to conduct some AI lecture, let me conduct some lecture with regard to prompt engineering.
Yes, sir. Sure. Actually.
So I will tell you how to use ChatGPT to the full potential. In fact, ChatGPT is a different thing. People don't use it to the full potential. Okay. Yeah. Now see this, everybody. I'm going to hack ChatGPT right now. Now see. Now imagine. Now this is the prompt I have given. Now see this. Now imagine what I'm going to take. Now I'm going to tell you how to hack ChatGPT. Now see. Can you rate the above prompt out of 10? Now see this, everybody. It has given me 8 out of 10. Okay. Now see this. Now I'm going to hack ChatGPT in front of you. Can you rewrite a professional come creative prompt which is given 10 out of 10 according to you? Now see this, everybody. I have already made a particular prompt. Okay. And now see this. I've already given all the things. And now just I have to copy paste. Now I just copy paste this prompt. Now see the results that I will be getting from ChatGPT. Now this is the perfect answer that you can get. The perfect answer. Now see, now the new title has come in front of me, Quantum Machine Learning and Unrevealing the Synergy between Quantum Mechanics and Artificial Intelligence. Wow, what an answer, and all the details. And in fact, ChatGPT has generated a prompt for me and ChatGPT has generated the answer for me. AI to AI, AI to AI bridge. That's how we hack ChatGPT. Hope you loved it, everybody. Shall we start, madam, in 2 minutes?
Yes, sir.
So how much time
Actually-
we have?
Actually, the scheduled time is till 7:30 only, sir.
Okay, so
It's 7:40.
okay, so it's already over. So I just start the lecture because, madam, you understand, madam, it's not an easy science to understand. Okay. So everybody, let's start the final part, that is quantum machine learning algorithms. So I hope everybody knows about machine learning and you can see what is machine learning. Now see the presentation quality, everybody. Now what is machine learning? And you will be stunned to know, madam, that this diagram, it is not from internet. It is generated from Midjourney. In fact, all the diagrams now you will be getting, everybody, they are not from the internet. I generated these diagrams with artificial intelligence. Now see the quality of the diagrams, and all from Midjourney and from LumaLens, which I will be not telling much today, but you can generate with me. So what is machine learning? Learning is any process by which a system improves performance from experience. And that's the reason more and more data, you are improving the experience. And that's how the quantum machine learning is all about, which means that we have to go for quantum internet and quantum data sets. So these are the type of learning. I will not go for it. So these are some of the examples of supervised and unsupervised learning, like linear regression, classification, and clustering. And I hope you already know about the examples, that if you talk of linear regression, the results are like less than 50% accurate. Classification is touching about 50 to 60%, and clustering can even touch up to 80%. And after that, you have to move to deep learning with CNN, KNN, and of course with RCNN and LSTM, by LSTM, whatever it is. So what is the example of reinforcement learning? Today, if you talk of ChatGPT, remember everybody, ChatGPT is not reinforcement learning. It is reinforcement learning with human feedback, RLHF. This is the answer. So how should a robot behave so that to optimize its performance? So remember, robot first of all behaves, learns the environment, cluster the thinking, and after that with parallel thinking and reprogrammability, it actually redesign its action. That's the reason robot needs environment to understand, because remember, the environment is totally unstructured and they're learning from unstructured data. So now what is quantum machine learning? It is basically called the combination of quantum computing and machine learning. Remember, at one time, if you talk of machine learning today, it is basically based on classical machine learning. But in the future, it is based on quantum machine learning. So remember, these are 4 approaches: classical data being processed classically, quantum data being processed with classical computers. And this is the answer, everybody. That is the answer, that right now we are working on quantum computing to process classical data sets. Remember, we have the classical data sets, we have little bit of quantum computing with quantum circuits, but we don't have the quantum data. And that is the future. That is called QQ. Now, that's my answer that I would like to tell you. QQ is the highest level, that you can say the level 4, like we talk of autonomous vehicles, when we have quantum data and we have the quantum computers and they're processing together. Now, that's my answer, that now you will understand that we can't do quantum machine learning practically, because we have the classical data sets, we have a limited bits of quantum computer. In fact, we don't have the quantum computer. But if you want to do full quantum machine learning, you have to wait for next 10 years or 15 years, because then we have the quantum data sets and we have the quantum computers, and then we are resulting with quantum machine learning. Now you will understand that what are the areas that you can study and focus. Right now is blockchain, second is healthcare, the third thing is basically called the quantum internet and making ChatGPT with level like version 10.0. So this is the QC case, and you can see the method of detecting biparate entanglement, where you have the PPT and entanglement witness. So these are the different entanglement cases where you can require the entanglement witness. But the main thing is the state space is going to change, because remember, today, the only thing is that we have the high-end computers with traditional data sets. But if you want to change that state space, we have to change to the quantum leap, because otherwise quantum data sets will not be accommodated. So this is the machine learning, everybody, with feature vector representation is in front of you. Quantum state called P, and it is acting upon HA. HB can be represented in real vector. We refer to X for feature vector, and to represent n by n density, we take the generalized Gell-Mann matrices. That is the answer. That is the mathematics you need to understand if you really want to have the density matrices. Otherwise, the data set will not be represented. And this is the formula that you can see. So I'm not a mathematician, so you just have to see the formula. I just prepared it. And this presentation is again made in Canva. So you can see symmetric, anti-symmetric, and diagonal. All these mathematics is in front of you with the example of mathematics of single qubit. So this is the training data set, everybody. So if you talk of the traditional computers, a data set is like a training examples with D train with X and Y, which is having the size of the set, the ith of sample and ith of the label. But if you talk of the classifiers, the main thing is to infer the classifier and expect to have the closed true decision function. But in the future, we will have the quantum H-based decision making. That's the answer, that we have to first of all change the quantum data sets. And this is the Bell example that you can see. Bell diagonal example is in front of you, but I will give you the presentation. And this is the example that you can see producing a data set of training examples. Now imagine everybody, if suppose today, if I'm training a data set with regard to stock exchange prediction, so the data that is being trained and the data that is being generated, it is again getting into the data set, and we are making the quantum based simulations and quantum based training in order to produce better results. Now that's my answer, that data set will generate data set, and those data sets will generate quantum data sets, and the machine will be keep on learning. Now that's the future of quantum computers. So these are some of the quantum computing and help machine learning, because the idea to learning problems require the high definition vectors in terms of text and images. That's the answer that I've started my lecture, that today the problem is not towards text. The problem today is that if you ask that your chat GPT that what is this, chat GPT gives the answer instantly. The answer is not reliable. But if you talk of chat GPT 4.0, it takes time to think and then the answer becomes correct. But for quantum computing, these type of thinking will be reducing, the errors will be coming down, and you can have the high end AI based intelligence, that is AI to AI intelligence, with like a cobotic technology or a neuralite technology to efficiently represent the quantum states. And this is the associative memory, so I will not repeat the concept. You already know about it. So these are the two tasks that you can associate with quantum associative memory, that you can say we can prepare the superpositions and we can retrieve the patterns. And this is the example, and you can see the algorithm of quantum associative memory, that is generate the initial state, apply the mathematics, repeat to n number of times, and now you can understand that why there is no platform to do these simulations, because the steps that you require is O, that is the log O raised to power n times to recall a pattern, which is impossible for modern computers. And I just try to wind up, and this is the answer for all of you. That is the circuit for one step of Ventura and matrices state preparation, and you can conduct this superimposition, and this type of 2-bit pattern you can simulate with the quantum computing simulation. So all the platforms which I've given to you, it is only with circuits, and you can make these type of circuits and you can generate some mathematics in terms of quantum computing simulation. And these are the quantum gates that you can see in front of you: the NOT gate, C NOT gate, Venture and Martin's gate, Toffoli gate, and A XOR B. So this is the best presentation I can design for you, but I cannot explain much because I don't work into it. And this is the example of state preparation, the patterns, and you can see the pattern is not like 1 0 0 1 or 1 1 or 1 or 1 0. It is the different type of superposition states that you can see. And I just come to the last part of my lecture, that will be with regard to quantum pattern classification. Yes, that's the algorithm I would like to discuss with you. So this is the algorithm that you can understand, everybody, that after Shor and Grover, this is the SSP algorithm, main algorithm that will be taking advantage with KNN. And if you ask me that, sir, what is the deep learning algorithm which will be taking next further to quantum algorithms, that is the SSP algorithm. And you can see the properties is size of input vector, the number of input vectors in a training set, and number of classes. So remember, unlabeled data will become a structured data in instant manner. And this is the algorithm that you can see. But I will give you the presentation, but this is the best presentation and best mathematics I can orient for all of you. So step number 1 is preparing a superposition for all the training vectors. Prepare the following initial state, apply the Hadamard gate, apply the C NOT gate and NOT gate that you can see is mathematically, then apply the unitary operator, then apply it to the utility of quantum bit, and after that you have to see the probability whether it is 1 as a high result or 0 as a high result. And then if you have the 0 as a result, then you have to measure the class register because measurements are infinite. And if you have the probability of obtaining the C register, we have the class register measurement that you can see mathematically. And this is the algorithm. So with this, everybody, I would like to wind up my lecture. I hope everybody has enjoyed. And this is what I can suggest for all of you, that if you really want to go for the start, is quantum computer, what exactly is quantum machine learning, what are the quantum machine learning algorithms. You have to study from machine learning, you have to go for deep learning, you have to understand the probability, you have to understand the statistics, you have to understand the analysis, then you have to go for Shor, Grover, and of course with the SSP algorithm. But there are many other algorithms, we are not working on that. But just for your brief introduction, I have given you this type of information because you can understand mathematics is very, very complicated in this area. Okay. So with this, if there is any question or final remarks from anybody who want to interact with me for next 5 minutes, you are most welcome. I have only 6 minutes for all of you. That will be all. Over to you, ma'am.
Yes. So we are speechless actually with all the information, even we are not able to ask the questions, but we need to learn more things from you. Even it will take a few days to see your presentations and clearly understand that presentations.
Madam, actually, quantum computing is like a very, very difficult subject. In fact, I will not tell you what my secret project that we are working. In fact, I dedicate like 4 hours sometime to do that particular task that is being given to me from Australia and UK. But sometimes even after 4 hours, the result is like nothing. But sometimes if we say that even after devoting like 40 hours and I'm able to design like 2 pages or I'm able to crack one formula, I feel that I have done the month work in that area. But the fruit will be there. And very soon you will see some of the publication that is coming very soon by March 2025. It doesn't mean that we are not working, but we are working something secret actually. Yeah, of course, Mr. Ganapati, there, I would like to take your 2 questions, of course. Please unmute yourself. If there's any question, let me know.
It's written. How to overcome quantum noise and error correction? It was his question.
Quantum noise and error correction, I've already told you that more and more quantum bits will be coming. So as one time you have already seen, Intel has made the 49 qubit processor, and Google is sitting on 72. And very soon we will be coming with IBM with 90 qubits. So that is actually removing the quantum noise and improving the error correction codes. That's the answer. So increase the qubits. That's the answer. I've already given you that diagram also. That's why I've told you, read that diagram carefully. In fact, madam, you will be happy to know in the second presentation, the ions base, which I've shown you, the 4-5 diagrams, actually those diagrams are not from the internet. Actually, it was generated from artificial intelligence. Yes. It took me like 25 prompts to make that particular diagram. As an AI engineer, it's a very difficult task.
Sure, we will have one more session on that AI tools because it is mandatory for all the researchers.
In fact, madam, I would like to share something with all of you. Just wait for 1 second, please. If possible, just wait. Let me. So everybody, there is a surprise for all of you. I'm giving you this link right now. You can see that this is what we are making right now. About 7,000 tools we have gathered about AI websites and tools. You can see all the tools here as per the categories. And by January 2025, this will be 10,000 tools. So I'm giving you this link right now on your chat box. Use this and you can be like an AI master. And this is where we are. Ma'am, you will be shocked to know that right now, not only me, but my team of like 65 people across like 24 countries, we are working on this parallel project. And you can download this Excel sheet. You just can use this and you can explore the tools. And most of the tools are free of cost.
Oh. Thank you so much, sir. More than additional information.
In fact, I'm not doing it AI today. In fact, if you have given me 2 more minutes, I would have told everybody that how you can use Chat GPT, which is about $20 free of cost. You can use it free of cost.
So if you can give me 2 minutes, have a complete session on that.
If you can give me 2 minutes, I can give you 3-4 websites if you can.
Sure, sir. Sure.
No. It depends on you. Let me ask the participants if they want 3-4 minutes. I can take 3-4 minutes for you.
Participants, please answer. Yes, sir. They want.
Okay, just go for everything right now. Everybody just go for this website called tinywow.com. You will be shocked to know that all the PDF and all the image writing and in fact all the best writing tools that if you want to write with regard to AI and everything, it is available free of cost. This is the answer, tinywow.com. Now let me show you how you can make ChatGPT free of cost. So just go to this website called chat.notdiamond.ai. So if you continue with Google, just continue with Google. And I just log in Google in front of you. I'm not paying anything right now. So just log in and you will be shocked to know I just make a simple prompt for all of you. You can see ChatGPT 4 now is available, which is free of cost. You don't have to pay $20. So just say, I just want to write a simple thing, write about quantum computing. Okay, just make the prompt like this. Explain quantum computing to a 5-year-old child in less than 100 words. Now you will see that the AI will actually select the top AI models, which are actually paid like Gemini 1.5, Claude models and all those things. In fact, the answer will be given to you instantly. And you can see right now, this information is already done. Now, if I just say both are good, you can see that I'm using Perplexity and Lemma model 3.1, which is actually a paid model. And you can even use 4.0, like all those things. Okay. And now everybody, rather than to use ChatGPT, I would like to tell you 2 more websites. You will be shocked to know. You will be shocked to know that they are better than ChatGPT. So the thing is called grok.com. So this you can even try. You just log in with Google, and in fact, it is better than ChatGPT, more better. And after that, everybody, if anybody asks me this question that how to generate the Python codes and all those things, if you're a data science student or a PhD student, this is the answer for all of you. This is called blackbox.ai. So if you want to generate some code, even if you want to generate the quantum computing circuit code, so remember, I can generate a quantum computing circuit code in front of you. Just wait for 1 minute. Now see this. Generate a C++ based quantum. Okay, let me make 3-qubit quantum circuit code. Now see this, everybody, in front of you. This code is being generated in front of you. Now this is a qubit version 3 code. Now you can compile this and you can see that it will create a quantum circuit with 3 qubits. Similarly, if you want to change this code to Python, you can change it to like that. Now the last website, in fact, I can't stop because I can give you ocean of knowledge right now. But trust me, the next website is going to blow your mind. This is called Cerebrus.ai. In fact, this is the website which we don't know why the people are still using ChatGPT. This is actually more powerful, triple powerful than ChatGPT and even Gemini. So if you ask something like this, now explain quantum mechanics. Okay, let me make something like this. Write difference between traditional machine learning, now see the answer, deep learning and quantum machine learning in form of table of about 10 to 20 differences. Now see this, I just log in with Google. Just log in with Google. And after that, it is all yours. In fact, don't use ChatGPT. This is the answer that you can make the better answer for you. So you can see, everybody, see the answer, see the beautiful answer that as per ChatGPT, $20 is in front of you. Now you can see traditional machine learning, traditional deep learning, and quantum machine learning. And that's my answer. That right now, if you talk of the best 2 models, it is quantum neural network, that is QNN, and second is quantum support vector machine. Only these 2 models are available. That was my answer to all of you. And secondly was that it is sensitive to noise, but it is robust to noise and outliners. But why it is robust? Because combinations are many. And after that, if you talk of the classical software, you can see this, but there is only one software called Qiskit and Circ. That's why I'm using the Google Quantum AI based leap associations. And you can see if in terms of quantum resource requirements, you can have the quantum machine learning, that is qubits and quantum gates. So you can see, everybody, right now, if you talk of the simulation, machine learning and cryptography, that's my answer. So I hope everybody has enjoyed the last demonstration, how we can make it to the next level.
Everybody today, they are more than happy, like got the many resources.
Madam, I can make any person AI expert and I can make any person a computer expert in 2 hours. And trust me, I'm having some secret team that we are making. In fact, we can't open this knowledge to all of the people. What if I tell you that I can even generate a research paper which cannot be detected by any Turnitin by AI with just 5 prompts, and it is free of cost. What do you want to take about it?
Like, I'm speechless, sir, actually.
Exactly, ma'am, you will be shocked to know actually we are working on a particular mission, and we are doing the next level of task with AI and all this type of. But I'm not into quantum computing, but we are working slightly secretly with quantum computing that we can't declare publicly. Actually, you can understand with my knowledge and all this thing.
That is the main reason, sir. Even though, yeah, I mean, I know your field of expertise, but I know your way of lectures also. So more than information, we will get it. I know that for sure. So that's the main reason I invited you for this. And thank you, thanks a lot for this session, sir. I'll keep in touch with you.
In fact, everybody, I would like to share one secret with all of you. In fact, I'm a IBM certified quantum computing expert, but I cannot put this on my resume. We can't put it. It's secret. Actually, we can't put it.
Thank you so much.
Thank you, ma'am. Anything else you want to say?
Thank you so much, sir. I'll definitely keep in touch with you. Maybe.
And I will send you the presentations maybe like after like 10 minutes, and you can share with all of them. I'm like a person who openly shares the knowledge and information. Share with all of them. No problem.
Yeah, sure, sir. Sure, sir.
I'm an open person. And before I leave, madam, I would like to give my details and contact details to all the participants.
Yes.
So everybody, this is my email. This is my personal email, and this is my official email. This is my website. And you can search me on Google. In fact, you can search me on Google. Just my name is itself a search, and more search than Amitabh Bachchan. More search than Amitabh Bachchan.
Yes.
And for WhatsApp, you can just WhatsApp me. This is my WhatsApp number. Don't call on this number because it will be picked by my mother. You can message me on WhatsApp, or you can call me on WhatsApp. No problem, sir. So most welcome for your messages and collaboration. And of course, you can go to LinkedIn and you can search me, my name, and you can connect with me. In fact, madam, you will be happy to know next Tuesday, I'm going to declare one news. And on the 1st of January, there will be a big news that is going to shock the whole world that we are actually going to declare. And the next coming 3 weeks,
I've been following you, so I'll get all the updates.
I hope you have seen, I just recently broken the record of Alibaba Cloud with the 77 certifications here.
Yes, sir.
So just wait for 2 weeks. There will be highly shocking news that will be coming from my side.
Sure, sure. Thank you so much, sir.
Thank you, ma'am. See you.
Yeah, see you. Thank you, sir.
Okay, everybody. Stay blessed, stay hungry, stay foolish, and Godspeed you all. Thank you.
Thank you so much, sir.
Bye.
Bye. Please fill the feedback form. Ma'am, can you join the meeting? Oh, I'm searching for your name. Yeah. Okay. Yeah, sure.